I watched the machine build a working feature this morning. 30 seconds. It compiled, it ran, the demo was clean. And in those same 30 seconds, it made a dozen decisions I never saw it make. How the data gets stored when it talks to the database. What happens when something fails. One of those is a hairline crack. You won't see it today. You'll hit it as a wall the day you get real users. The machine wrote the code. It also wrote a decision you never read. For as long as I've been doing this, the hard part of software was never the typing. Fred Brooks said it back in 1986. The difficult part is deciding what to build and how the pieces fit. The design. Writing it down was always the easy part. Well, the machine took the writing down. The design didn't go anywhere. It's still being decided, just silently, by the model, while you watch the demo. You're not the architect at the blank page anymore. You're the auditor of an architecture that already exists, one you didn't draw and can't see yet. Every builder I've talked to fell into the same trap. The demo working is not evidence that anything is built right. The machine builds for the demo. Clean inputs, one user, a handful of rows, your laptop. Every failure that ever hurt these people was invisible in exactly those conditions. The query that's instant on 50 rows and deadly on 50,000. The error swallowed so quietly nobody logs it. The bill that reads 0 in development, it ran, tells you about the demo. It tells you nothing about the design. So let's do the thing the demo can't. Let's audit 3 decisions the machine made for you and watch each one break. You asked for all your orders, with a customer name on each one. The machine wrote exactly what you said. For each order, go fetch the customer. 1 trip to the database, per row. On 50 test orders, it's instant. You'd never notice. On 50,000, it fires 50,000 separate queries to paint a single page. And you can't catch it by reading the code. The code looks clean. The flood is down at the database, out of sight. Nobody wrote a bug here. The syntax is perfect. The flaw is the decision. A loop. 1 trip per row. Instead of a single join, one bigger request that grabs the orders and their customers together in one go. And that flaw only exists at a size your demo never reached. That is what system design actually is. The decision, not the code. A builder put this better than I could. The machine kept adding new tables. The schema, the blueprint of how your data is organized. Instead of simplifying until starting over clean was faster than fixing the mess. It never designed that blueprint. It grew it, one prompt at a time. And it leaves quiet traps. Think of an index like the index at the back of a book. Without one, finding a single thing means reading every page. The machine skips them by default, so a lookup that should take a millisecond quietly reads the whole table instead. It's correct. It's just silently slow, right up until real data shows up. So ask any blueprint, the machine hands you one question. Was this designed, or did it just grow? If it only ever grew, nobody was minding the shape. And shape is what you pay for at scale. The machine's default is the simplest thing. Call the other service, wait for the answer, assume it works. That's 2 silent decisions in one. It blocks. While it waits, other requests pile up behind it. And it doesn't retry. Real calls fail. 1 in 20, sometimes more, a timeout or a rate limit. With no retry and nothing to stop the pileup, one hiccup becomes an outage. Fine at 10 users. A meltdown at 1,000. So trace every call that leaves your app and ask 2 things. Does it block? And does it retry? The machine almost never volunteers either, because at demo scale, it never had to. They're one lesson wearing 3 masks. And there's a name for the thing the machine keeps getting wrong. It's in Kleppmann's book, The Standard Text, with a new edition out this year written with Chris Ricco Mini. Every system, he says, comes down to 3 concerns. Is it reliable? Does it scale? Can you maintain it? The runaway query was scalability. The sprawling schema was maintainability. The blocking call was reliability. Every time, the The machine optimized one corner. Does it work right now? And went quiet on the other two. It doesn't feel the 3 a.m. page or the growth curve, so it doesn't build for them. Your job is to check the 2 corners it never mentioned. I've watched this same movie for 35 years. Every wave promised the machine would take the hard part. The mainframe, client and server, the web. Each time, the tools got better at writing the code down, and each time, the same decisions were waiting underneath. How to store it, how to scale it, how to keep it alive. The tools kept changing. The trade-offs never did. This is the newest tool in that line, and the fastest. It clears the busy work more completely than anything before it, which is exactly why the real work, the design, is now the whole job. And you don't have to. You need one question asked of every feature the machine hands you. What happens to this at 100,000 rows? At 1,000 people using it at once? With someone actively trying to break it? With one network call that fails? 4 conditions your demo will never show you. And the 4 places these decisions go to die. That question is the whole audit, folded into a reflex. Ask it before you ship, every single time. No tool is going to ask it for you. That part is yours. You can. Genuinely, more than ever. But not by trusting the demo. You own the architecture, the machine drafts, you read the decisions, you check the corners it skipped. That's the system design skill of this era, not drawing the diagram, auditing the one that drew itself. And the deepest of these decisions isn't in the code at all. It's one layer down, in your data, where a schema choice made in a second decides whether your app is even correct. That's where we go next. Thanks for watching. If this changed how you look at the code the machine hands you, pass it to someone who's building alone. Subscribe to AI Tech Book. Next time, we go one layer down, your data layer, and why it decides whether any of this is correct.